To start designing custom components, it is important for the user to download an accurate datasheet and have a good understanding of what the dimensions mean and how tolerances work. The mechanical structure of the component is drawn first, and then this is linked to the schematic symbol. The user should find the section of the datasheet which discusses the physical size and shape of the component. This section will normally give all relevant dimensions of the component as well as manufacturing tolerances associated with each dimension. The user needs to pay very close attention to the tolerances and design the component footprint to accommodate the biggest possible dimension where appropriate. For instance, it is important to make the physical length and width of the component big enough to accommodate the biggest dimensions with regards to tolerance. However, the pin should always be the median of the tolerances, as pins can usually bend from the median point to fit the minimum or maximum hole spacing. The user will need to open a PCB Library document to store the custom components. In the project window, the user should right-click and select Add New to Project PCB Library from the menu. A document will be added to the project which has a similar look and feel to it as the PCB document editor, the difference being that there is no black area representing the PCB. Many of the tools are similar, however, and the layer tabs along the bottom are still present. The user should start by placing the pinholes for 3-hole components or solder pads for surface mount components. Both of these tasks are carried out using the same tool. Placing the holes or pads first will normally give the component some shape from the start. To make the process of placing the 3 holes or pads a lot easier, the user should first set up the grid of the document to match the pitch or spacing of the pin or pad. For example, if the pitch spacing between the pins is 2.54 mm, set the grid spacing to 2.54 mm. To place a hole or pad, click the Place Pad tool on the toolbar. By default, a through-hole pad will appear on the mouse pointer. As with any component in Altium, if the user presses the Tab key on the keyboard before placing the pad on the document, the Properties window for that pad will appear. Here, the user can modify the size and shape of the pad to the specifications listed in the datasheet. Most of the properties are self-explanatory for users familiar with PCB design. However, a couple of properties are critical and need further explanation. For a through-hole pad, the hole size property needs to be set to the maximum diameter of the leg pin of the component plus about 0.25 mm to allow for easy installation. If the component is a surface mount device, there will be no hole, so this property should be set to 0. For a through-hole pad, the layer on which the pad sits is multi-layer. This will place a solder pad on the top layer and bottom layer and also allow the user the ability to connect the pin to any internal layers that may be present on the PCB. The user should make sure that the plated property is checked when using this type of pad. This will ensure that an electrical connection exists between the pad on the top layer and the pad on the bottom layer. A surface mount pad will only sit on one layer, and for the purposes of drawing the mechanical layout of the component, this layer is the top layer. The user will notice that when top layer is selected as a layer for the pad, the hole size property is automatically disabled and the hole through the PCB disappears from the preview pane. The user can then change the size and shape of the pad to fit the appropriate dimensions of the leg of the component. A good datasheet will have a recommended PCB layout for the pads, which will make this step a lot easier. When the user is happy with the size and shape of the pad, they should click the OK button to return to the PCB library. The pad attached to the mouse cursor will have been updated to reflect the changes implemented by the user. If the grid of the document has been set up correctly, the user will simply be able to click consecutive points on the grid to place pads precisely. Every time the user places a pad, the next pad will automatically increment its value to the next number. No two pads are to have the same number, as Altium uses the number of the pad to match up with the component pins on the schematic symbol. When all the pads have been placed correctly, the user should right-click to cancel the Place Pads tool. The next step is to place an outline of the component body onto the footprint. The outline of the body is usually placed on the top overlay layer. This body outline should be large enough to define the maximum boundaries of the body of the component. This will avoid the problem of components being placed too close to each other when it comes to mounting the components onto the PCB. The outline of the body of the component does not have to be an actual representation of the component, but it must define the maximum boundaries of the component as accurately as possible. The design of the body shape should be made in such a way that a person soldering the components to the PCB will know the correct orientation and rough shape of the component. Use the measure tool to check any distances used in the design of the component body. This can be accessed by pressing Ctrl and M. Right-click to stop using the tool. Another hint is to make sure that the boundary of the component does not touch or cross any of the component pads. The clearance of the component body outline from the pad should match the default setting for the design rules. This will allow for simple soldering of the component to the pads. If any top overlay overlaps the solder pad, then this will limit the ability of solder to flow across the pad. When the user is ready to draw the component outline, they should firstly set the grid to something with enough resolution for them to draw accurately but also precisely. A fine grid is usually the best. Next, the user should select the top overlay layer using the tabs at the bottom of the document window. The user has a number of tools that they draw the component outline with. The main tool is Place Line, located on the toolbar. This allows the user to draw straight lines at any 45 and 90-degree angles in much the same way as tracks are drawn on the PCB document. Another set of tools are the Place Arc By tools. These allow the user to place perfect curves on the component outline, which is particularly important for electrolytic capacitor bodies. These tools can also be used to place dot markers on pin 1 of ICs as well as IC notches for correct orientation of chips. The user can also place descriptive text, dimensions, and solid polygons on the component body if required. The user can also place 3D bodies onto the component footprint. This is particularly useful for developing 3D models of the PCB for modeling within the enclosure of the final product. To place a 3D body onto the footprint, the user should click on the menu bar, Place 3D Body. A new window opens that gives the user a number of different options. The most simple and accurate method of placing the body is to use a generic step model supplied by the manufacturer of the component. It is common for ICs and connectors to be supplied within 3D models. If the model has been supplied, the user should select Generic Step Model in the 3D Model Type section of the Place 3D Body window. The user can set some minor parameters to help identify the model, like giving it a descriptive name and appropriate color, but the main button to use is Embed Step Model, which is located in the Generic Step Model section of the window. The user simply has to select the model step file and Altium will import and embed the model into the component footprint. The user may need to change the angle of orientation of the model using the X, Y, and Z rotations, but this is simple to do once the model has been embedded. The user should click the OK button and Altium will place the 3D body onto the component footprint. The body will appear as a 2D image on the Mechanical 1 layer. If the user wishes to view the body as a 3D image, then they simply need to press the 3 key on the keyboard. This will change the view mode to 3D. To return to 2D mode, the user simply needs to press the 2 key on the keyboard. The 3D body, if accurately drawn, can be used to line up pads and outlines. If there is no 3D model of the component that has been produced by the manufacturer, then the user can make some very basic shapes using the other tools listed in the 3D body tool menu. Extruded is used to make simple cuboid shapes. Cylinder can make tubular shapes which can be used for component legs as well as bodies. Sphere can be used to make rounded ends and joints of components. If using the basic shape tools, make sure to give each different shape a descriptive name for the purposes of simplifying editing. The simple shapes can be difficult to line up accurately, but can be useful if the Altium coordinate system is used accurately. A PCB library may contain many different component footprints. Each footprint will need to have a name, properties, and a description associated with it. These parameters can be accessed by clicking on the PCB Library tab at the bottom left of the main window. This tab displays a list of all the components contained in the currently selected library. Double-clicking the name of each component will open a small component properties window where the user can input the component name, height, and description. These properties should be as detailed as possible in order to distinguish the component footprint when required. Each pad and line used to illustrate the selected component is listed in Component Primitives section of the PCB Library window. With all of these tools, the user should be able to produce a professional and accurate component footprint. The PCB library should be saved to a usable location and may even be included as part of the project directory. In a professional environment, the PCB libraries are often kept in a document control system so that all component footprints are kept up to date and any mistakes can be corrected relatively quickly. The schematic symbol is a functional representation of what the component actually does rather than how it physically looks. Sometimes the best representation of a component can just be a rectangular block. Sometimes it is a symbol commonly associated with that type of component. The first step is to open a schematic library to add the component to. This could be an existing schematic library or an entirely new library. To create a new library and add it to the current project, the user should right-click in the Projects tab and select Add New to Project Schematic Library. A document will be added to the project which has a similar look and feel to it as the schematic document editor, the difference being that the toolset is drastically reduced. The next step is to add pins to the component. For a simple item like a resistor, this is simple. However, for a complicated component like a 128-pin microcontroller, this process requires a systematic and careful approach in order to avoid mistakes. The user should select Place Pin from the Drawing Tools menu on the toolbar. A simple pin is placed on the mouse cursor. The orientation of this pin can be changed by pressing spacebar on the keyboard. The properties of this pin can be changed before placing it on the schematic by pressing the Tab key on the keyboard. In the Pin Properties window, the user is able to change the pin name, designator, type of pin, pin description, add symbols to the pin, and position the pin accurately. The designator is of particular importance as this will be directly matched to the corresponding pad number on the footprint. Placing a backslash after a letter in the display name field will place a line over the letter which it follows. This is used to indicate an active low pin, which is normally logically high until something pulls it down. When the pin is appropriately set up, the user should click the OK button to proceed with placing the pin on the schematic symbol library. Once a pin has been placed, Altium will automatically increment the pin designator to the next number. The pin display name will not change or increment unless it has a number placed at the end of it. Once all the pins have been placed in appropriate positions and labelled accordingly, the user should draw an appropriate symbol to represent the component. Many of the basic electronic components have standard symbols which should be used where appropriate. Microcontrollers are generally made up of ports, lines, and power ports. It is sometimes useful to collate these pins into their various ports even if the pin numbers do not always flow consecutively. Most microcontrollers can be represented by a rectangular block. To draw this using Altium, select Place Rectangle from the Drawing Tools menu located on the toolbar. The user is required to select the diagonally opposite corner boundaries of the IC. As with any item drawn in Altium, the user can double-click this rectangle to edit its properties. The user can also place lines, freeform polygons, place text, place arcs, and many other shapes and symbols. Once the user has completed the component shape and pin layout, they will need to add the physical component footprint to the symbol. This was designed in the previous step. Click the Add Footprint button located at the bottom left of the Schematic Editor window. The Library Browser window appears asking the user to find the component footprint from among the installed libraries. The user should navigate to the library in which the correct component footprint is contained and select the appropriate footprint. More than one footprint can be added to a single schematic symbol. This is particularly useful for components like resistors, which can come in a variety of shapes and sizes. The schematic symbol properties are very important and should all be filled out as much as possible. To access the schematic symbol properties, select the Schematics Library tab at the bottom left of the main window. This tab lists all the schematic symbols contained within the library. Double-clicking the name of the currently selected component will open its properties. It is important to fill out as much information as possible and make the properties descriptive. Of major importance is the designator. The designator should be given a short title, all in capital letters, with a question mark at the end. This allows Altium to automatically increment the designator when using the Annotate Schematics tool. If the component is a generic passive component, then there is no need to include value information. This is only required for components that are generally unique. Adding parameters can help with documentation control if required. More footprints can be added using the Properties window. The user can add as much or as little information to the schematic symbol as they desire. Once they are finished with the schematic library, they should save it to a usable location. A component can be added to the schematic or PCB by adding the appropriate library to the project. If a schematic symbol is used, the library containing its respective footprint must be added to the project as well. Otherwise, Altium will be unable to find the component footprint when it tries to add the components to the PCB document.